Okay, so I'm going to get started working through the review. I'm going to start on the one that says no calculators show your work. And then I'll do the other one directly after. Find an equation for the plane which passes through the point P, which is 1, 3, 1, and contains the line x equals t, y equals t, z equals minus 2 plus t. Okay, so this is the line. Let me write the direction vector for this line. That's going to be 1, 1, 1. So that's the direction vector for the line. Okay. I also know a point on this line. I'll call it Q. It's going to be 0, 0, minus 2. Right, I just took t equals 0 and I plugged it in, and then what's left is this. Okay, so I need to find the equation for a plane. So I need a point on the plane. I have that. And I need the normal. So how can I get the normal? Well, I can get the normal by taking the cross product of two vectors that lie in the plane. Well, I know that the direction vector lies in the plane because it tells us that the plane contains this line. So all I need now is one other vector that lies in the plane. And how can I do that? Well, what I'm going to do is I'm going to create the line P, or the vector PQ. So this is minus 1, minus 3, minus 3. And this is also going to lie in the plane because both of these points are already in the plane. So the difference will still be in the plane. So now I have two vectors that lie in the plane. I can do the cross product to get a vector that is orthogonal to both, which will be my normal vector. I, j, k, plus, minus 1, minus 3, minus 3, 0, 0, minus 2. Okay, so I, that's going to be 6 minus 0, I hat, minus, it's going to be 2 minus 0, j hat, plus, and that's just going to be 0, k hat. Okay, so that's my normal to the plane. Now I need to find the equation for the plane. So I do n dot x, y, z equals n dot any point that's actually in the plane. Okay, so I know that P1 is in the plane, so I'll just do n dot P. So here I have 6x minus 2y equals n dot P, so that's going to be 6 minus 6. Okay, so this is going to be the plane 6x minus 2y equals 0. Or that could even be simplified as 3x minus y equals 0. Okay, so real quick, this is the equation for a plane, not a line, because z could be anything, right? Z could be 1, z could be 2, it could be anything. So this actually describes a plane, not a line. Number 2, find the tangent vector r prime at the indicated point and parameterize the tangent line. Okay, so find r prime of t, so r of t is t plus 1 I hat, t squared plus 1 j hat, t cubed plus 1 k hat. And it tells us at the point 1, 1, 1. Okay, so our prime, that's not derivative, our prime, well, this is just 1, or I hat, plus 2t j hat plus 3t squared k hat. All right. So we want this at the point indicated. Well, real quick, we notice that here r of t goes through this point. There might be multiple times when it goes through that point, but for sure we see that if t is 0, right, if we plug in 0, we get 1, 1, 1, we get this. Okay, so here we know that the tangent vector at 0, that's going to be 1, 0, 0. Okay, so we need the tangent line, and it says parameterize the tangent line. So we can write this as x of t, y of t, z of t equals 1, 1, 1, right? Our point on the line plus t times our direction vector. So I want to distribute this, so I have 1 plus t, 1, 1. And I would go ahead and write them as separate. So I have x of t equals t plus 1, y of t equals 1, z of t equals 1. And that's my answer. You might be able to get away with this answer, but I don't know what kind of grading scheme will be used. Okay. Number 3. Find the distance from the point to the plane. So from the point P, which is 3 minus 5, 2, to the plane 8x minus 2y plus z equals 5. Okay, so we have the formula for this. We have ax plus by plus cz plus d. So remember, for d, we need to move this to the other side, so we get the sign correct, over a squared plus b squared plus c squared. Right, and that's just the norm a, b, c. That's just the norm of the normal. Okay, so we have 8 times 3 is 24. This is minus what? Minus 2. Minus 2 times minus 5, that's plus 10. Plus 2. Minus 5. Remember, I had to move it to the other side, so it's negative. Over square root 64 plus 4 plus 1. Okay. So that's going to be 34, 36, 31 over square root of 68, 69. So if you factor out a 3, you get 23. Yeah, so that's about all you can do. Number 4. Find a vector-valued function that traces out the directed line segment from P, which is 1, 4, minus 2, to Q, which is 3, 9, 6. Okay, so the really quick way to do this would be T times P plus 1 minus T times Q. And this would work. It's a little bit more work than we need to do though. Oh, sorry. No, this would work very quickly and you can do that. I'm going to show you the way that if you just didn't think about that, how would we find this? Okay, so we have P, we have Q. I want the direction vector, so I'll just find the direction vector, PQ. So that's going to be 3 minus 1, that's 2. 9 minus 4, that's 5. 6 minus 2, that's 8. Right, so that's our direction vector. Okay, and then we know that it starts at P, so we have the equation 1, 4 minus 2 plus T times 2, 5, 8. And that's my answer. I guess maybe I should set equal to X, Y, Z, or something like that. L equals, I don't know. Okay. Number 5. Find the cosine of the dihedral angle between the planes x minus y plus z minus 1 equals 0 and 2x plus y plus 3z plus 5 equals 0. So we have n1, which is 1 minus 1, 1, and 2, which is 2, 1, 3. Right. Okay, so the cosine between the two planes is the cosine between the two normal vectors. So this is n1 dot n2 over norm n1 norm n2. And that's just regular multiplication because these are scalars. This is a dot product. So we have 2 minus 1 plus 3 over, that's going to be square root of 3. 4 plus 1 plus 9 is square root 14. So that is 6, 8, or square root 3 times 14, that's 30, 42. Not even going to bother simplifying that. Okay, number 6. Number 6. Find the length of the curve. There's not going to be arc length on the test, so I'll skip it. And find the radius of curvature. Same thing, I skip it. Okay, so that's actually everything from that first test, from the first review test, or first of the old tests. So now let me move on to the next one. Okay, given points, you know what? I'm going to go ahead and do this in a separate video.